is the point, is the depiction at the point you are going to determine. So that is also where you are going to apply the load. Then if you multiply displacement and that unit load, it becomes the external virtual work. So that is the external virtual work on the other side. Now on the right side of the equation, you have integral of 0 to L times small letter m and big M over EI dx. Okay. Now the dx match with the integral sign. Okay. Now this small lowercase of letter m must be expressed in terms of x, and also the big M must be expressed in terms of x. Okay, what is this big M? Big M is the moment equation, no? The moment equation of the entire length, no? So that's why you have 0 to L. Okay? So in some cases, if the loading is not continuous, ang mahitabo na is you are going to make uh, multiple equations of moment. As long as it sum up the whole length. Okay? It could be by segment AB, segment BC. So as long as the sum of all segments equals the total length of the beam. Okay. Now, similarly for little m, the same what you are going to do. So whatever you've done to little to big to uppercase letter m will also be done to small lowercase little m. Small what I say lowercase of letter m. Okay, letter m. So uh, only that the load for small letter m is unit load at the point where you determine the deflection. Whereas the expression of m or the big letter m is the moment due to the real loads. So we have here virtual and real. That's why this is called virtual work. Okay? So in our example last week we had this, no? So our what is 0 to 10. Okay, and we have a cantilever beam. And then if I'm going to uh, we determine this. Uh, I think we determine this. Okay, we determine this. Okay, that's one, no? So I'll just maybe uh, make that as a color red. Then I will use this kind of line. Okay. So so the displacement we are looking is somewhere here. How will I do that? No, this is here. Okay, I will maybe say big D, no, big D. Because I'm using big D because if I'm going to convert that into symbol, it is delta. Now I want to maybe format. I'm going to put no line, no line. Okay, so that's the delta we are looking, no, before. Okay, so we divide this into real load and virtual load. So I divide this into two, real load and virtual load. So for the real load, of course you have the cantilever beam, 10 meters, A to B, so loaded with 12 kilonewton per meter. Now, so that you can come up with the moment equation, it is necessary to cut, no, to cut. So into two, you have the hand left hand structure and the right hand structure. Basically, you divide this into two. Now, it depends on which one is you feel comfortable to use. In this case, in my solution, I use the right hand side. No? It's the right hand side. Okay, so this is the one. Now, you can actually have an arbitrary origin. Here, my origin is on the right end. I going to the left end. There's nothing that's still all right as long as what you do here is you do also to the other type of loading, which is the unit load. Okay. In that case, you are fair. No, you're fair because what you do here is the same as you did here. Okay. Now, if I'm going to establish this as my point of origin, then I'm going to sum up moment about here. I could have m going clockwise, so clockwise positive, plus this 12 is acting downward, so this will still rotate in a clockwise manner. So I'll have 12 times x over 2. That's why it extends 12x squared by this. Or this will become, if I'm going to transfer this to the other side, this will become negative 6x squared. Okay, I am free to use a limit 0 to 10, no? 0 to 10. So that covers the whole length already. So there is no need for the secant segment because 0 to 10 can be, meaning you can apply this moment equation from 0 to 10. Okay, but it's not always like this. So there are cases where you cannot use the whole length. Okay, in my next example, I will find it out. So this is the equation, no? And this equation is good from 0 to 10 or for the whole length of your beam. Okay, so that means that the whole length of your beam is already somewhat taken or considered. Okay, and the length of the beam is only 10 meters. Okay, okay, this is your big M. Now, if we are going to determine the formula, it's only the small letter m. Now, let us work for small letter m. Okay, and the small letter m, that is what we call the unit load. Now, question, where I am going to apply the unit load. Okay, now you apply the unit load. It says here, determine the displacement at point B. Okay, so I apply it at point B. Okay, now since I assume already a downward deflection because the load is going down, so therefore my unit load is acting downward. Unit load at B, like in that way, acting downward. So this is now my load. Now, as I have said, what you did here is you cut. So simply here you cut also. And then since I am using the right hand equation, then I also use the right hand equation. And then same origin, okay, same manner of establishing equation. So I am a moment at this point. So I have m times 1 times x. So I have m negative x. Okay, small letter m is negative x and big M is negative 6x squared. So their product will be positive 6x cubed. Okay, so this one. So then integrating it, and you will have 0.15 meter. That's the depiction of B. Okay, so that's how we get it. No, that's just a recap of what happened next week, last week. No, so I make it smaller. Okay, don't worry because I am going to upload this. No, upload this. Now, for example number 2, which is our topic for this afternoon, is we have different type of beam. Still, this is what we call the simple beam, no? So, support by pin at A and roller at C. So, what happened here is we will have a reaction. Okay, so I will insert a reaction. This one I can use it. This is for reaction. And I probably make that be how much? Maybe make that 30. Okay, and the color like that. Okay. So that will be that's what called reaction at A. Now B is a support also. So there is a reaction also. Okay. 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 So we call this reaction at A. We call this reaction at C. Okay. So the problem is determine the displacement at B of the steel beam in figure. Now make sure that the value for modulus of elasticity is there and moment of inertia is there because if one of them is absent, not meaning that the material does not exist. Okay. Like for example, if E is zero, so meaning that a material with zero property, it does not exist, so you cannot see it, no? How about if there is no dimension, no? because I is a function of dimension of the member. So if you have I equals to 0, meaning that the dimension is 0, no? Very thin. Or in fact, it does not exist. So meaning I the two E and I should exist so that to make the beam real, okay, exist in reality. Okay. So anyway, we are going to determine the D, the depiction of D. Okay. So what happened here? I'm going to draw. No, I am going to draw the depiction. It will be like this. It will be like this. No? So I will shift. So first, if I only consider this load, so it would be like this. Okay, and then because D is there, so uh, this is only due to load, and then C to D there is no load. So that means that this one is it's not a good idea. So I'll have to redo that. No, redo that. Yeah, yeah. I will. Okay. What I'll do is I am going to add. No, I'm going to add. I'm going to add a line which is tangent to the curve. So it will be like this. Okay. So that's what happened to your structure, really. No? That's what happened to your structure. Now I am going to make this big. I need to make this the 2 points. Also this one, 2 points. Okay. And I'm going to convert this into a line like this. And then this one. Then maybe I'm going to doing this. Do. Okay. Now I am interested here. No? I will copy this one. I will copy this one. Home, copy and paste. So I can move this to diyan dito. Node na inaluktok. Okay, obedience. Okay. Take it for this. Drag it here. Drag it here. Drag it here. Ayan. So it's here, no? That's the delta. Delta D. Okay, delta D. Yeah, put a subscript there. Yeah. D. Put a subscript and then that one will be area. Okay, that's delta D. That's the depiction. So this is how it ano. So muna yan depiction. Okay. Now the moment equation here, the same thing. We use this formula. No? We use this formula. I will copy that. And if I'm going to determine the solution here, uh, okay, that's B. So if I'm going to determine the solution here, this is the reaction. We have to calculate the reaction. No? To calculate the reaction. So you still use this formula. You still use this formula. Okay. In small letter m is the virtual work due to the unit load, and this big M is the virtual work due to the real load. So I make a table actually of uh, I make a matrix here, no, comprising of what we call real load and unit load. Okay. So this is the real load. No? So the reactions are BE and BC. This is BC. No, that's not BE, but BC. There's no B because B is the point where the load is being applied. Okay. So reactions here. We have here we have BA equals to 5 EN puno na siya because of the torque that is being present here. And then here also you have BV, B, B equals to 5. So I think that is negative. One of that is negative. Yeah, B is negative. Negative. This is negative. Okay. So how is that negative? How is that negative? Okay. So to explain the negative is you sum up, consider the whole structure, you sum up moment at A, I'll say here, summation moment at A equal to 0. Now this one is a subscript, so you subscript, you should be a symbol summation, okay? If we sum up moment at A, then uh, we have positive, I will say, positive clockwise. Okay. So what happened is you will have 120. Okay. Then you have another clockwise force that's 30. 30 the moment arm of 3 to make that kilonewton meter. And then we have also minus BB times 6. Wala na lang load is equal to 0. So this is BB. Okay. So if I'm going to perform the mechanical fluid BB, then so you have 120, you have 120 plus 90, 110 divided by 6. So BB is positive 35 kilonewton. Okay. Now, you can sum up the same. You can do the same, but maybe you perform that at C. Okay, the same, but make this C. So what happened is that same thing. You sum up moment at C. You have 120 rotating clockwise. Then you have VE plus BE rotating clockwise in the action positive that we have BE times 6. Then you will have minus 30 times 3 is equal to 0. So from there you can have BA. You can have BA. So this is A, this is B. Okay, this one has to be computed. So you have 130, 30 is transposed to the other side, it will become positive 90 minus 120. So you will have a 90 minus 120 minus 120. That's 30, negative 30 divided by 6 is negative 5, meaning that this is not the plan. Anyway, that's it. Okay, so that is to determine the reaction. Okay, BE and BC. Now, uh, the whole length is divided into AD, BC, and CD. Now, that is divided in this manner because there are a lot of chains of loading. There is discontinuity of loading. It's not like in the first example that the 12 kilonewton per meter is throughout the length. Here, uh, the load changes. Okay, EV different set of loading, DC different set of loading, also CD. Okay, so we divide this into three. That's why in determining the moment equation big M and moment equation small m uh, is threefold. No, so you will have MAB, MBC, and MCD. Okay, like that. So that because this formula requires from 0 to L, and 0 to L is comprises A, B, B, C, and C, D. That means that you are going to add the moment of AB, moment of BC, and the moment of CD. Okay, so that is what we mean by 0 to L, no? 0 to L. So we are going to calculate the load, the M, big M for yellow. So that's why I divide it into three, no? Instead of using MAB, MBC, MCD, I am going to use M1. M1 represents for the moment equation of AB, M2 represents the moment equation for BC, and M3 represents the moment equation for CD. Now, since we are going to determine the moment equation from A to D, that means that we have to add all these three moments, M1, M2, and M3. Okay. Now, whatever you did here for the real law, you have to be fair also with the small letter m. Okay. So, like for example, you divide it into three. So you divide it into three. Then this is not M1 all, no? So sayop ni siya, sayop ni siya. Ato na siyang i-reason, no? So like that. So okay, we have already determined the reaction. Now my objective here is to determine M1 or MAB, whatever, into, or sometimes you call this as M subscript DC, M3, sometimes you call it subscript CD, no? Is to determine all this moment by considering either left or right equation. Okay. So if I'm going to determine member AB, so this is what happened. Maybe I'm going to write this as AB. AB. Okay. AB. Okay. Now this is the first segment actually. No? So if I'm going to show you where is that figure. That figure, this is the one. Okay, this is the one here. Okay, that's EB. I am going to not okay, and then the color could be yellow. Okay, so this is the first, no, for AB. No, you can determine moment of AB here. So considering this, now it becomes -5. You might wonder why it becomes why it becomes positive when what we get is negative. You can change it positive provided you change also the sign. Okay. Now I sum up moment here. No, I sum up moment here. Here, so I can determine M1 here. I just go back to M1 no, para consistent po sa figure. Okay, M1. I have 120 going clockwise, so you have 100 M1. Supposedly it's like this. No? Supposedly it's like this. Copy here. Yeah. So what happened is I'm going to sum up moment. Sum up moment somewhere here. So I'll have M1 minus 120 I think I'm going to use summation moment equals to 0 positive CCW, meaning positive counterclockwise. Okay, I have M1 positive counterclockwise minus 120, and then you have plus 5x. This is equals equated to 0. Okay, 0. Now, transposing 120 to the other side, so that's why we have this. Okay, that's for M1, no? Now, for M2, you need to consider this side, that side. So, again, in your cutting, so I can consider the other side, no? So, this is what happened for member BC. So, the only load there is this one here, this one here, BD, this is 35. There is no load within the beam, okay? Because this 30 kilonewton load is at point B, at point B. And if this is our moment, so basically we sum up moment at B. This is B here. So B actually, do not say 30 kilonewton, but the moment arm is 0 here. Here, there is a load here supposedly. I will insert it here. There is a load here. I'll say load here. Okay, I'll say load here. And that load is 30, but since I sum up moment here at B, okay, sum up moment at B. Let's see here. Sum up. Here I will see B yapon ko, no? Sum up moment at B. Okay. Okay. Pero sadly, my x is only up to 0 to 3, no? Limit is only 0 to 3. Limit is 0 to 3. Whereas the beam is really 10.5 meters long. So that means that this one is not really complete. No? So here, remember BC, you sum up moment somewhere here, sum up moment here. B also is equals to 0. And this will be M2. M2. M2 rotates in a positive manner, and then minus 35 times 2 equals to 0. No, x, 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 x times it. So that's it. So you have M2 equals to 35x. Now your limit is from 3 to from 6 to 3. 6 to 3 because your one is here. 6 to 3. Limit is from 6 to 3. This is point C. So C is here, 6 meters from A, 6 to. But you can still use 0 to 3 here, no? 0 to 3. Okay, 0 to 3. Because you're using local origin, so 0 to 3. Here, still 0 to 3, because 0 to B. So, in other words, of the 10.5 meter long, only 6 meter pa yung nabuhat. So, you need this one as your third. So, here, for member CD, you sum up moment at C. You sum up moment at C. C equals to 0. Now our limit is 0 to 4.5 meters. Okay, from D to C. Yes. Okay, so submission moment at C. So C here. So what happened is that entry is basically no load, so 0. Entry is equal to 0. But the limit is, since this is C and D, you know that C and D is only 4.5 long. It's only 4.5 long, C to D. So, and then you start here, on your diagram, this is your starting. So, you can see 0 to 4.5 only. Okay? So, you have entry equal to 0. So, in terms of local origin. Okay? So, 0 to 4.5, you have 4.5 here, 3, 3. So, if you sum all of the length being considered, you have total of 10.5, and that covers the whole length already. Meaning, this 0 to L for big M is already satisfied. Okay. Now, whatever you've done for determining the M is you have to be paired also with the small letter m. Okay. So, like for example, this one you cut them into three, so there will be three, no, three. So what you'll do is you are going to determine the support reactions using this one. So if I am going to consider this as uh, actually I can insert here. I can insert. So mauna siyang reaction din. Reaction, you can call that VE. Let's change color. Okay, maybe the size and change it. No. Change, change the size. Okay, then copy that. Okay, so now if I'm going to determine reactions, so I can say that VE is equal to 4.5 divided by 6 is equals to minus 0.75. 0.75. Now I will not put kilonewton. I will just use I will erase this kilonewton. Do not include the kilonewton there. It's good not to include just the unit load. Just the unit load. Okay. Just the unit load. Okay. So that's why my VA has no unit. Okay. It's better that way. No unit. Now to determine B sub B, of course, B sub B is 1 times 10.5, 1 times 10.5, 10.5 divided by 6, 1.70, 1.75, okay, 1.75. So that the sum of the vertical load is 0. Okay. Now, if I am going to consider this figure, I will have a figure like this. I will have a figure like this. Okay, for member AD, okay, member AD, you have member BC, you have member CD. We are going to make equation that say I am going to determine for member AB here. So this is the diagram for member AB. Member AB. Member AB. Okay. Now, ay sum up moment at A, no? Sum up moment at A. Ano, somewhat here, here, at B, some summation moment at B. So what happened if I'm going to sum up moment at B, sum up moment at B. Here I have M1, okay, counterclockwise, so this one will be small letter M, M1, and then there's no other load, still positive, still positive, 0.75 with a moment arm of X. So this one is negative 0.75 X as your small letter M. Okay, so that's it, 0.75X. And for member BC, our diagram will become like this. For member BC, okay, that's it, no? Member BC. So member BC. So now this is B, C, D. So no, yeah, B, C, D, no? B, C, D. So only from C to D. So whatever you do in big letter M, your origin is in the support. So here, your origin is also here. Okay. So summing up moment at B equals to 0. The sum up moment you get, okay, limit from 0 to 3 also is you will have into in clockwise. I think you don't have to include this because only this one. You need to B to C. And then this is only CD. So you have into. And then opposing is 1.75. 1.75x is equal to 0. So therefore, and this one will be letter small into. So I'll have yeah, so include na po na ko ang 1. Ang 1. Include yapon. So, ang hitabo lang sa isa, wala lay load sa D. Dini kinaamay load. So, ma-include yapon na siya. No? So, it will be included here. So, na siya plus. Okay, plus, if you sum up moment here, this one rotates in a counterclockwise. So, that's 1. But the distance, you know, from B to D is equal to X plus 4.5. So that's it from 0 to X to 4.5. So this one is still variable, but it's only up to 0 to 3 limit. So this one is already 4.5 on this point. So my equation for M2 is this one. Okay, M2 is equal to 0.75x. Okay. Minus 4.5, because this one positive transfer to the other side, it will become negative 4.5. This is 1x minus 1 minus x plus 1.75 equals to positive 0.75x. So that's it. That's the inflow. Okay. So for member CD, whatever you've done here for big M, you still do it here. The way you establish the x, the way you establish the equation, the way you establish the limit is still the same. So we just put it here. Copy that. Okay. But this one will become small letter m. Okay, okay. But the figure looks like this. Okay, so that's the figure. That's the figure we are looking. Okay. So here we sum up moment at C. So in here, so I will have entry. I will have plus here, plus 1 times the moment arm x. So that gives me entry equals to minus x. Okay. Now its limit is 0 to 4.5. Okay, so we have 1 to 1. So this one shall be multiplied with this because it's big M and small m, or big small m to big M. They should have the same subscript when they are multiplied. M2 must be multiplied with this small and big M with the same subscript, and the other one M1, so small big M and small m with the same subscript has to be multiplied in order to get this equation. Because you have three moments, because we divide them into three finite lengths, such that the sum of all length is equals to L. So we have three equations containing integral, no? So our equation will be like this. So following this, so that will be our guide, home copy here. That will be our guide here. It's perfect. But good thing that M13 is 0. So if it M3 is 0 here, M3 is 0. So anything that will be any number, whatever magnitude is that, it will be multiplied with 0. So it will become 0. So instead of having three terms, it will become two terms na lang. No? Two terms na lang. Because the last term containing the subscript 3, one of that is 0. So what happened is that supposedly you're having this equation. So this is the equation, virtual work equation. So this is the virtual work equation. So first is that one. Okay. That's the virtual equation. So virtual work equation. Okay. So we have three M1, M1, M2, M2, but this one, since big M3 here is 0, so we have to put that as 0. Okay. that is 0. So, I will insert tick box there. That will be 0. Okay. And maybe I will, okay, so that is 0. So in other words, I will have only this one. No, I will have only this one. I will have only, okay, so what happened is, I will have only this. The other one is 0. Okay. And then continuing, as you know already, small letter M1 and big M1, so you just multiply it. So finally, you will have this one. So substituting, substituting M1 and M M1 into M1 M1 and into our equation. Okay, and that, so it's big. So and that 1 times delta D. So I remove actually the kilonewton. I remove the kilonewton with before because I don't want to use unit here. So you have this one is not already there. No? So also for this one, so wala na siya. Wala na siya. Okay. So just like delta D. Now, so the answer for delta D actually, delta D is equal to this. Okay, so that's it. So you have a negative answer, negative D. Okay. Meaning that why we get a negative? That's the question. Because we know that this is positive, it's above the read line, and yet we apply a negative. So I have mentioned that if you do that, the magnitude is still the same, but only the sign will change. So that's the question here, why we have a negative answer. Okay? And the answer is that in your assumption of virtual load, the unit load is going down, whereas the actual deflection is going up. Okay, so that's it. Okay, so that is actually how we recalculate the detection. Yeah. So I'll save this and then maybe so in that example class, there is a change of loading. No, that's why we need to divide them into three segments because we cannot use the same equation throughout. No, we cannot have a single equation for the whole lead. Okay. It's not like in the previous example that we can only use equation from 0 to 12 because from 0 to 12 there is no change of loading. However, here from A to D there is a lot of changes of the loading. There's a what you call that what you call that yeah, change of loading, no, change of loading, or so that will be an obstacle in the equation. Okay, so what we do is that we divide it into segments. So AB we can express an equation that is valid for from A to B. Then BC we also express an equation. No, actually it's valid to the other length, and then the last equation is valid. So in other words, that because the equation requires that it's the strain energy of no, what do you call that? Is the internal work of the whole length. So that means you are going to sum all the what you call virtual work of the whole length. That's why we have M1, M2, M3, and big M is for the moment expression for real load, and then big small letter m is the moment expression for the virtual load. Okay. So whatever you do for the big M, you have to be fair with the small letter m. So like for example, your assumption of your local x-axis, your origin about the x, so it should also be the other one. The way you establish the equations of moment is the same point, no? So meaning M is just a shadow, no, of what you did to begin. Okay. So the reason why we have three equations is because you cannot express one moment equation for the whole length. Okay. So maputol-putol yun siya. Tawag siya finite length. Okay. So that's how we do, no? So uh, uh, another one also that I'm going to follow up here is like for example, maybe I have a follow-up example here. Follow-up. Follow-up example. This is still based on the first example, second example. No? So I will make this big. So I will use the same figure. I will use the same figure as this one. Okay, I will use the same figure. Copy, but maybe I will post it here. Yes, I'm going to change this. And use B. So in the follow-up example, I have it here. I will say that this one, no? Determine the displacement at point B. So rather you make here, no? You make here. Okay. So you can make an equation here. One. Now you can have only two segments here. Two segments. Okay. So uh, you'll have I will have number for small letter m. I'm going to insert a table here. Okay, so this one is for the big real loads, real load. This is for the N. This one is for the virtual load, small letter M. Okay. Now, same. I will apply the. I'm going to insert a shape. It will be here. Okay, so that's one. Okay, so I am interested here, so I will apply a unit load here. No? So you can only have you can only actually slice here. You can slice here. You can slice here. So you can slice there. So color. Okay, I can slice there. So I can here segment EB member EB. So you'll have X equals to 0 to 3. Then I can have also member B D. Okay. X yeah, member BD. I just say member BD. Okay. So what you did here is the same thing you will do here. Okay. Okay, so if that is the case, the same maghapon, no? Ang AB, no? Ang AB. So, ang mitabo sa imo ani sa real load and ni siya figure nimo. Ni siya figure nimo. Okay. Pwede mo. Ini lang. Tapi ni siya. Okay. Whereas ang isa lahi na, no? Lahi na. So, mitabo sa isa is kinahangit mo. Mag-doing kita. Okay. So, muna siya okay. See. Okay. Yeah, naani siya support din eh. Naani siya support din. May support niya. Piyahon ko na siya. Pati din niya support. Kasi so, ang tabunan na is determine ang deflection. Insert shape. Small siya nito. Okay. So, mo ni siya ang itawag due to virtual load. One. So, because of that, doon na kay reaction din eh. Reaction diha. Okay. 0.5. Okay, 0.5. So, ma-determine mo ang delta D actually. Na may delta D din. Okay, that's the whole vertical deflection delta. And then as far as one, so the same BA here, BA is equals to yeah 5 for that direction, and BB here is equals to 35. So you will get the same equation because the same figure here for BC. For BC is equals to 120 minus 5x. That's in BC. In AB is equal to, I will use the M1 equation. 120 minus 5x. 120 minus 5x. 120 minus 5x. Okay. So that's one. So if you are interested in the figure, you will copy in this one. Okay, that's the figure. And then for member DD, what's this? D to D, I can have this member DD. Yeah, just this one. Yes. Okay, and then I can have member MDB is equal to, I think, 35x from here. 35x. Okay. So now for EB here, you use equation like this. So we will have M1. M1, if I'm going to cut it here, I can have M1 minus 25x is equal to 0. So you have M1 equals to 25 x. This one is small letter m. This one is a subscript. This is a subscript. This one is m. Okay. So it's small letter m. Okay. So the figure could be like this. Okay, class, I will stop at this point, no, because we don't have time. So, anyway, this is just a follow-up question if you want to determine at B. No? So, the thing is that you have to be paired with a small letter m. Whatever you do in establishing equations and your point of origin in the figure should also be reflected in determining the moment equation for small letter m. Okay, so uh, basically, uh, in that example, I have uh, discussed how to determine the deflection of the beam, no? Using finite length of the beam in the substructure because we cannot express a single equation throughout the length. Okay, and then following the equation of the virtual load method. Okay, so let's go to your schedule for your exam. Your exam will be Monday next week. Monday next week, same time, 12 to 1:30. The exam will last 90 minutes, but I will design it in maybe 60 minutes only, but I'll add 30, so you will have 90 minutes all in all. So the exam will start opening exactly 12 because I am going to time and learn. Now, 40% of the item is multiple choice, and 60% will be problem solving. Okay, there will be a problem solving, and then maybe I will have to be creative to divide them into items. No, so there will be some calculation involved. Okay, calculation that the answer is still there. Okay, so it will include trust deflection. So maybe I will put a table there and you will have a table. Okay, for the trust deflection. I will have also similar to what we have discussed. Maybe I will use the cantilever beam, no, but different loading, not 12 kilonewton meter. So find the deflection, yeah, something like that. And then also for shear and moment also, we are going to do shear and moment. So you should uh, yeah, for the shear and moment. So 40% multiple choice and 60% problem solving. Okay. That will be on Monday 12 to 1:30. So that is all for this afternoon. And then yeah, I know you have some concerns, so please tell me. Hello.
Hello, sir.
Yes, yes. Princess Yapa. So you have some concern?
Wala po, sir.
Okay. So
I mean, okay na.
midterm will be on Monday, 12 to 1:30. 40% multiple choice, and the rest is problem solving. Problem solving involves shear and moment equation, shear and moment diagram, given the load diagram, finding the deflection of the thrust. I will supply the table and you have to fill it up. Maybe I will use a simple task, maybe for 4 members, so that it can be easily can be done on time. And also the beam deflection using virtual load method. Okay, so I think that's all. And there will be no class on Monday because that is midterm week already. So Monday, and then our next class will be on Thursday. Okay, I will still meet. I think what is like for tomorrow? No more. We will not meet. We will not meet. We will meet on Thursday next week because Monday is midterm, still midterm week. Okay?
Sir,
Hmm.
mangayo pa kag clearance?
You have to. That is the instruction to us. No? So you please. I will. I will. Tawag aning make page where you can submit your clearance. No. So I will just put here submit your clearance here. Okay. So I will the submission will be up to the time when you take the exam. Or I will time it yeah during the midterm week. So anytime you can submit. Okay. Beginning tomorrow, I will just do it this evening.
Sige sir, salamat sir.
Okay. Any other concern? Clearance? What else?
Ay, sir, if wala pang clearance niya but sir, ba, pwede na may send lang ang kanang picture nga nagbayad na may.
Ano mo pa man abot yung clearance? So,
Like
pag
kung, kung dugay makabayad sir ba?
Actually, I do not know what the e-learn does that because in some other school, they cannot. I do not know if that is activated in e-learn that they cannot really. They are. I mean that they cannot. What is the term? They cannot take the exam. No? Just because there is some deactivation in the part of the e-learn on that particular class. So I do not know if e-learn does that, no, but it can. Uh, just do your best that you can submit your clearance.
Okay, sir.
Okay. I will also give one. But I do not really encourage that. No, but you will be taking some special exam because special exam I will really make it special. No? Like that. Okay. So it's already time for my next class. So uh, thank you for coming, class.
Sir.
Thank you, sir.
So let's go.
Thank you, sir.
Okay.
Thank you,
Thank you,
sir.
sir.